Hi there, and a very warm welcome to this screen recording part of this session. So I have made a poll on Twitter, and you decided in favor of the 32-bit OpenEXR workflow. Well, there was 1 hour left, but it didn't turn the tables in that 1 hour. So here you go. We have a EXR workflow tutorial in front of us. So what is EXR workflow? So basically there are two ways to store your data. Either in a linear fashion, which is described in linear float, 16-bit float or 32-bit float, or as an sRGB or with a gamma curve baked in image. And this is mostly the case with 8 or 16-bit images. Now, as I said, EXR is just one type of file for storing a float 16-bit or 32-bit image. But as far as I'm concerned, it's the most versatile and the most useful file format simply because of its flexibility. So let's go on with the slides here. So the major difference between those two types of images is that the 8 or 16-bit image has baked in gamma, as mentioned before. And this is the case because of a phenomenon that occurred with computer screens early on. And if you want to know more about it, you can check out my tutorial on Vimeo about the linear workflow. And basically, it's all tightly integrated into the same construct. So if you want to learn more about this and a bit more in depth than I will cover in this lesson here, you can watch that tutorial. It's rather old, but things don't change that quickly, so it's still relevant. Now, when it comes to rendering, both of those files have to be brought into the render engine. And the render engine basically understands linear math, and therefore the sRGB image has to be linearized, while a floating point EXR, for example, doesn't. It already contains all the data that the render engine needs, and it doesn't have to be processed before rendering. And now that's the interesting part here. So after rendering, either you save out your files as a linear 32-bit or 16-bit float file again, or you go ahead and save it as a JPEG or PNG as a 16 or 8-bit file. But at this point, you're only halfway through the pipeline. Why? Because what's happening is you're saving out a file again. And basically what we watched right now is the 3D software side. And with that output file, you go into compositing. What's most important is that you keep the quality of your pipeline as high as possible for the longest time. And in the end, you can decide what format you export to. But if you're doing an 8 or 16-bit conversion and bring that into your compositing, you're jeopardizing dynamic range and other things inside of your pipeline already. So you don't have the full possibilities inside of your compositing package. And this is really important to know. So what are the big advantages, you might ask? Well, you might have noticed that I put in some extra arrows inside of this graphic here. And this basically indicates one of the greatest strengths of the EXR or of the 32-bit floating point format. And this is that you can have ranges that go beyond black and above white. So you basically keep a lot more information inside of your files that you can later retain in compositing. We'll go over the benefits of this kind of pipeline later, but first let me show you how to set up a pipeline with floating point EXRs in Octane. For this purpose, I already have opened my meter scene. Let me just render it for you so you can see what it looks like. And let it load. It takes quite a while because there's a lot of textures in there that need to be loaded. So let it just load for a bit and hopefully it will start right now. Okay, so here, this is how it looks like for those of you not familiar with the scene. Basically, I also within the scene have split up every light source within a different path, so I can recombine it in compositing. And when doing this workflow, it's really important to get all the informations over to your compositing package, because if you don't, you will lose on quality, and obviously that's not what we want. So let me just show you how I set up my rendering. So let's go to the render settings. I have set up the render settings to output everything through the Octane output. Now, this is a special thing that other renderers do differently, but Octane can export everything through Octane and not use the usual Cinema 4D output system. You may have noticed that I have some cryptic text in here. I know this is not directly related to OpenEXR, but since it's a workflow thing and we are talking about workflows right now, let me just go over it real quickly. So what I'm doing is I'm telling the renderer, or Cinema 4D or Octane in that matter, to go one hierarchy back. If I only put in one dot, it means it will save the file in the same hierarchy. Then I will tell it to do a folder named renders. In my workflow, that folder is always called renders, so this way there's no mix-up. Now I'm typing $ and then PRG, and this way it takes the name from the project. It's called meters, so it will make a file that's called meters unless I put it in another slash, and this way inside of the renders folder it makes a folder called meters, and then for example I can call the project the same. So let me just copy that over there, and maybe that's not enough. You can see that I have render files for HD and UHD. So I also want to name the file after the render settings. So what I can do is hit $RS, and it's not redshift, it's render settings. So let's go through this one more time. I go one hierarchy back from where my Cinema 4D file is, then make a folder that's called renders, and make a folder that's called after the project name of the Cinema 4D file, and then make a file that is called like the Cinema 4D project name, and then call it after the render settings, which is in this case HD. Now that we've done that, let's go through the settings I use here. So first of all, if you're exporting from Octane, you should check the EXR Octane because it's more capable than the Cinema 4D standard EXR files. So if you normally use EXR to export, just use that one. In the compression settings, I usually use two different compressions for different types. So if I render still images, I use the PITS compression. It's basically the smallest compression that is lossless, so it means you get all the quality. If you want to go even smaller, so basically what this compression range is doing is going from the biggest file size to the smallest file size. So PITS is in the middle somewhere, and after PITS the compressions are not lossless anymore, so they are lossy. But it's not as bad as with JPEGs that you can see artifacts and really bad chroma subsampling. So what I do when I render animations is I usually render DWAB compression. And this gives me really good results. I never had a problem where the quality wasn't sufficient for my needs. And it gives you really small file sizes. The funny thing is that almost always the file sizes are smaller than a 16-bit PNG. And this is really nice. The next thing I would do is tick half float, because half float halves basically the precision of the EXR. But if you do not use any information passes like world position or something where the information is crucial, you can use half float and get away with that. Usually for image processing, you don't need that high precision of a full float or 32-bit image. Now half float in other terms also is called 16-bit. I never quite figured out what's the right way to say it, if it's half float or 16-bit float. But the important part is the float part, because that lets you keep the highlights inside of your file. So in contrast to many others, I also like to save my files in a stack of different files dependent on the name. So I don't use multi-layer files. The main reason I do this is versatility and speed. I mainly work with AfterEffects because Nuke is much too expensive for me as a freelance artist. And AfterEffects is giving me most of the options I want, but it's still very slow with multi-layered EXR files. I know recently that with the 2020 version they made improvements in terms of the capability of fast rendering EXRs, but still I like the way to keep my files separate, because sometimes I don't need all the passes that I render out and I can delete them later, the passes I don't need for compositing, that is. And also if I need to override one image pass with another information, for example if I have had the wrong depth, and can override the image sequence without touching other files. If I would have saved all my files packed in a multi-layer file, it would be very difficult to exchange single passes in there, and therefore I use one single image sequence per pass. Now if you render animations, you can choose to make single folders for every pass. I won't do that since this is a still image, and therefore I'm fine with that. So remember that we want to export all our light passes here. And I think now everything is set up. One more word of caution here. So if you go to the Cinema 4D save option, you don't want to save that, because this one here, if it has the same pass, will be overwritten by the Octane one, and you don't want that. And another thing, if you don't care about the Octane output and want to output your files the Cinema 4D way, make sure if you want to use linear, go to this rollout and choose float linear. If you choose float tone mapped, you get everything you set up in the camera imager, but you won't get any highlight details that would be lost during the tone mapping. So go to float linear here and then set up the OpenEXR 32-bit with a DWAB compression here. One other word of caution here is that a slightly older version of Cinema 4D, this was broken, so just try before you write out your files if it works, because I lost one night's render because it was broken and I didn't know. So let's pretend we rendered out our files, and so we can proceed to compositing and see what our advantages here are. So now open AfterEffects and make sure the comp settings are set to 32-bit per channel float and blend colors using Gamma 1.0. If you don't set this up here, we will get into trouble when we blend our light passes later. So let's bring in all our passes that we rendered. So let's select all and make sure you don't have selected a sequence if you have rendered a still image. Import, and then we grab the main and make a comp with that. All right. So this is looking good. And the first thing you will notice is that your info panel here is going from 0 to 1 instead of 0 to 255. And this is because we are now working in linear floating space. And the other thing you will notice, if I just zoom into a highlight, and if you look up here, and if I go to the highlight, you can see that we are getting values over 1. And this is basically the most essential part for the linear workflow, that we have this much information available later on in the process and not throwing it away. So for example, if I go to effects here and set an exposure, and zoom in again and lower the exposure, you can see that there's still details everywhere. So there's it's not burned in. And the cool thing is here that if you change that, you can see the effect that it would have if you wouldn't have used 32-bit. So let me just change that to 8-bit, and you can see with 8 or 16-bit, it would lose the detail, while with 32-bit, it's still there. So what else could we do? We could layer up our lights. So let me just choose all our light passes here and bring them into the comp. And what we would do here is just go to the blend mode and set this to add. And this basically will then blend together all of our light passes. And the cool thing here is that I can not only turn off and on lights, for example, those small LED lights, or let's see, what else do we have? The oscilloscope and maybe the glossy reflection here. Not only that, but we can change those lights according to our needs. So let me just find the light for the display here. Yeah, this one here. So if I go ahead and put an exposure on that, you can just lower or even overexpose it the way you want. And it has effects on the scene, so there's only so far you can go, of course. It's no overexposure of 6 stops or 6.5 stops. That's enormous. But you can see that it has an effect on the scene right now, and it's illuminating much more the surroundings. And if you remember before, I said if you don't use blend with gamma 1.0, it looks wrong. So let's just do that and try that out, and it looks kind of strange. So if I compare that with our original beauty pass, it looks off. And if I go back and set this on again, there is only a very small bit of difference, and this is mostly because I just change the exposure of that. So this is a very small difference here. So if someone knows why there's still a very small difference, I'm keen to know if anyone has figured this out, because I didn't. So a lot of you might ask, why are those damned highlights so important? And I will answer this question with this new scene I opened. So you can see that there are some highlights again that are blown out. And let's just go through the workflow I do normally to get the comp done. So basically, first of all, I do a vignette. And the vignette is just darkening the corners. And you can see if you look here right now that while I'm doing the vignette, the exposure goes down, and therefore you get highlight recovery. So if I go to an 8-bit file, you would not get a highlight recovery, but a dirty looking gray blob here. And this is not what we want out of our image. So it's much better if the highlights can be retained. Now, next I usually do some image sweetening, and I have just done this where I simulated some light coming in from the right side here. But the next thing is the thing I really want to emphasize here, and this is, I still didn't like the way the highlights looked. They looked kind of digital, not filmic. And usually film has a soft roll off here, so what I did is I used the curves and rolled the highlights off very softly. And what this was doing is giving me the feeling of much more dynamic range in the highlights, so you can see what's happening there. Yeah, so what I usually do then is go and add some chromatic aberration. I do this by going in here and porting this comp to a new composition and then adjusting the scale and adding those together. So those are just the red, green and blue passes. And I spread them apart by scaling them so I get the chromatic aberration. Last but not least, I put them in yet another comp and then just add some final adjustments as levels and grain. I always use grain because most of the screens nowadays are capable of displaying 8-bit, and some of them are very prone to bending. You know, the color stepping that is happening with soft gradients on them. If you use a slight grain in your renders or in your images that you put out, you can avoid those bending effects by basically dithering the result. Now you have to be careful here. The grain is a 16-bit effect. It will tell you here that it will, after that effect, use only the 16-bit colors in your comp. And for me, I use that mostly as the last effect, so it should be here. Now I, for some reason, have a use saturation in there that I didn't use. And when I use grain, I make sure it's the last effect in the stack of comps, and therefore all the effects are applied to a 32-bit linear image, and then I add the grain last to make it 16-bit or 8-bit, and then I save it out in whatever format I want. Now, if you want to go through with high dynamic range, if you need that for a film project that will be in HDR, then of course you can't use the grain because it will take away the HDR capability from your image. But if you're using it for everything else, for web or for normal cinema, 16-bit is more than enough. You can use it there. So the last step would be for any of my comps to export it in the format I want or that the client requested. So one more word of caution here. If you use the media encoder to export your files into a 8-bit file format and it's not 32-bit, you should make sure you have 8 or 16-bit effect here, because otherwise the colors come out very weird. You can describe it kind of like this, that the media encoder can't handle 32-bit colors or convert them to an 8-bit MP4, for example. So to help the media encoder to do this, make sure you have an 8-bit effect in here. And if you don't want to use the grain, there is, for example, the broadcast colors. This is an 8-bit effect, but it will just conform your comp to podcast colors, and it doesn't take away a lot of range or dynamics. Question to you out there: if you know of an effect like a depth converter inside of AfterEffects that I don't know of, let me know, because that would be much better than using any effect for this purpose. Alright, so thank you a lot for watching. I hope some of you learned something today. Yeah, so let's go back and thank you very much.